So this is going to be structured in 3 sections today. We're going to start off with quickly talking about design. Most of the content here is probably geared towards ISVs, building custom apps for consumers, for your employees, and larger agencies. So if you think of like, consulting firms like Touch Lab, something like that. Next, we're going to talk about actually how to build enterprise apps. So this is going to be going through APIs and content to help you. There's some code in here that I've added, which I'm pretty excited about, that was actually pretty hard to write and figure out. And finally, we're going to talk about how to deploy your applications. So let's get started with design. I frequently get questions about, we're on another platform. We have web content, we have, other mobile content, desktop content. How do we get started on Android? We have 100 apps. Where do we even get started with this? And I'm telling you, the first thing that everyone wants to do is hire an army of consultants to just do a one-to-one translation of their apps. And that's like the worst idea ever, in my opinion. You should really take the time to think about the feature set, modularize your apps, think about like how you can actually make a user experience good for your employees. So the first thing I want to mention is material design. Everyone here probably knows what that is, but just in case you don't, put a little bit of time and effort into thinking about it. If you don't have a designer on your team, there are actually case studies on the material design website that are similar to, if you think of it as like a bootstrap template, if you're aware of that, that give you some like a nice overview of a few specific design patterns that we've come up with. Especially if these are for like an internal app for your company, that's not a problem. No one else is gonna know about it. No one else is gonna see that they look the same as a lot of other ones, but at least still have some really nice colors, animations, and things like that to deal with. It's cross-platform, so you can make a consistent design across web, desktop, and mobile platforms. So if there's some new apps or some new things you want to add, feel free to reuse those concepts through all of the different platforms you're going to release on. So design stuff is important. It's good to at least put some thought into it. I mean, on the enterprise side, that's even harder. But the core of this is really talking about how do we build these apps properly. There's 4 sections that are important. Jetpack, which is not really a specific thing to enterprise, but I wanted to mention it. We're going to talk about security, single sign-on, and finally management. And managed stuff is a really important piece for building an enterprise app. So Jetpack. There's lots of talks on this. There's I/O talks on this. I think there was a talk here yesterday about it. I'm not going to say too much on it. It's a different and a new way of thinking about how to architect your Android apps. Please look into this before you start, if you're starting from scratch. If not, there are some components like live data, which kind of help with the observable pattern and things like that that are pretty important. So check that out beforehand. But jumping into the gold here, I think, of this talk is talking about security. So Android itself, we've hardened the operating system. It's harder to direct attack it. There are lots of different devices, lots of different OEMs out there. With every version, it's getting better and better. The ecosystem, that's Google Play and Managed Google Play. So we have Google Play Protect and other ways of securing apps and your data to make sure that apps are free of malware, unless you add unauthorized sources. And finally, we're going to talk about your app, which is the important part today. There's 3 sections here, which is security, encryption and device management, storage, and finally verifying the device you're on is free of rooted devices, simulators, things that aren't real, stuff like that. So let's talk about securing your network connections. The first thing you need to do is create a network as security config. This will allow you to either enable or disable clear text traffic. One nice thing here in Android Pie is, by default, Android Pie turns off clear text traffic. So this means if you want to make a regular HTTP call, it's not going to work. You're going to have to intentionally enable that with the clear text permitted equals true, and then you can actually add a subdomain there to say, hey, we're going to allow this one to work. And there's actually a real-world use case for this that I'll get to in just a few minutes. Another important topic as well here is understanding how to add custom certificates. So generally, we don't really advocate that you do this on consumer Android apps, but if you're a large enterprise, you might want to add certificate pinning, which means bringing in your own certificates so that your app will trust specific certificates so that you want to actually require an extra level of access to your application. And this is also part of the network security config. So as you can see here, there is a trust anchors subtag which you can use, and you can list any user certificates that you want to add to your application. So this is, as I mentioned, I had some code in here that was surprisingly hard to write and surprisingly hard to find. So one thing that we generally tell, again, about Android is you don't really need to do certificate validation and hostname validation, or if you want to check to see if code can be revoked. So what this code does is it basically says, I have a list of certificates. Please make sure that they're valid and they haven't been revoked from a CA. So Android itself does some of these checks, but if you are including your own certificates or you have some really, really strict requirements for that, you can run this code to do that. It looks mostly like boilerplate, which is true, except finding the right exact piece of code is extremely hard. So yeah, if you take pictures of this, I'll post this afterwards as well, but the reason why this is so dense is it's actually the full example, so this will actually really work. And keep this in mind because we're going to use this for several use cases on the next slide. So again, super dense, apologies for that, but not really. We have several different use cases here. We're going to start out with checking an HTTP URL connection, or URL connection. So if you, anytime you make a network call on Android, you can actually check the validity of the certificates pretty easily by asking for the server certificates from it and then passing it to that isValid method that we wrote previously. Another nice thing you can do is check SSL sockets. So if you're making a direct socket connection, you can check both the host name and the peer certificates as well, which is really nice. And this is like, again, using that same code, which actually does a revocation check. This also uses a host name verifier on the SSL socket. So if you're, you want to check, I know google.com is probably going to be okay, but let's say you have your own domain there, you want to check this out. You can use a hostname verifier to make sure that one, the hostname is verified, and two, that certificates aren't revoked. Finally, you'll see a custom network security config at the bottom. This is allowing the traffic for an OCSP or an online certificate server protocol check to happen, because those happen on port 80. So there's two sections here. There's one that is DigiCert and one that's for Google. So this will allow us to check the validity or the revocation of a Google certificate and anything that's on DigiCert. One example here is there's a website called badssl.com you can use, and it's really nice because you can actually check a lot of different URLs and make sure that your code works properly based on different types of certificate issues. So one really nice thing that Sean mentioned as well is that apps are sandboxed in Android, and they have a different security key or different encryption key for each profile as well. So as long as you're saving data in your application, it will be secure and other apps will not be able to access it. The trouble comes in when you want to share data with multiple applications. So if you have an enterprise that has a lot of different applications that need to share data between each other, you can do this with external storage, although one thing you might run into is now you have to encrypt it, because external storage just doesn't provide that feature for you. So another giant block of code will help you generate a key to encrypt your data. Again, this is something that is extremely hard to write and figure out all the different settings properly. I've vetted this with Android security, and again, this is actually something that really runs. So this code will generate a AES key. It will save it in the Android key store for later use. And there's also one nice thing here is that there's a new feature of Android Pie, which allows you to require that the device be unlocked. before using this key. So if someone picks up your phone and tries to take it, they can't get access to this key because it will actually not work unless the device is unlocked. And again, here are a few use cases where you can do this. So obviously when you generate a key and put it in the key store, the first thing you probably need to do is get the key back out again. That's actually pretty simple. You just ask for, the key, you say get key on the key store itself. If you do want to use a public-private key pair, so if you want to use like RSA or elliptical curve, you can do that as well. And the calls are very, very similar to this. And if anyone wants it, I can give you sample code after, I'll post some of this as well. The next thing is, depending on your requirements for security, you might want to make sure that your encryption keys are saved in secure hardware. So this means that if you're running on the simulator, you're not going to be able to get access to the key. Your key won't be saved in secure hardware because there isn't any secure hardware element, but if you're on a newer Android phone, it will be, and this means that your key will not be able to be retrieved or basically hacked in any way. The nice thing about that as well is that anytime the key is used, it's going to be running in TE, which is the trusted execution environment. So even though we haven't like a reference to a secret key here, you can't actually yourself get the actual raw bytes of that key out. Once it's actually in the key store, you cannot get it back. And that's for security reasons. And finally, let's do something useful, encrypt and decrypt. So again, this is mostly boilerplate, but the important pieces here with AES are to make sure that you remember that you have to keep your initialization vector, or IV, because you won't be able to decrypt anything without that. So along with the encrypted data, you need to keep the IV, which is the get IV section right there. And conversely, when you decrypt, pass all that same information back in, and that should work for you. So let's move on to how to verify that your device isn't compromised. So, if you're in the BYOD context, like Sean mentioned before, you probably don't want, folks bringing in rooted phones because this can kind of compromise all sorts of things on Android. So the Safety Net Attestation API allows you to attest or to verify that the device you're running on, you get some level of confidence that this device hasn't been rooted, it's running a real version of Android, and there's no apps that are harmful on the device. So just a quick example here. Safety Net is part of Google Play Services. The APIs on the client side are very, very simple. Basically, you call Safety Net API.attest, pass in a nonce, which is just kind of like a one-time use random generated ID that you can create. And you're going to pass that, once you get that back, you're going to pass that along to your server, which is a Java web signature, which is going to look something like this. The two pieces of important data on this are CTS profile match and basic integrity, which are on the bottom. And CTS profile matches, that's the compatibility test suite for Android, and that's something we run wrong. All the builds that we trust and we know are available, so that means all the real OEMs, we know it's a real version of Android. It's not someone built something to try to kind of build a device that can extract data. And then basic integrity means, we haven't found that this device has been tampered with, rooted, or any of the other things. There's actually quite a bit of other things that it checks that we can talk about as well. The next one is verify apps. So the important piece here is that Safety Net can also give you a list of potentially harmful applications on a device. So if Google Play Protect, which is constantly scanning your applications and constantly scanning what's on Google Play, notices something that's out of the ordinary and shouldn't be there, this is something that you can call, and it will return a list of potentially harmful apps to you. And this is something you can go through depending on your network administrators, your policies. You could have your app delete the, quickly notify or disable the device if it makes sense. You could notify or warn the IT administrators of that's happened. Any kind of thing that you should do. This is, obviously if you find that there's a potentially harmful app on your device, you need to let your security team know in some way, shape, or form. So let's talk about, single sign-on authentication. Currently, when you build an app, especially if you're building one app, it's pretty easy. You'll have some sort of login mechanism, That's fine. Nothing really out of the ordinary there. But what happens when you start getting multiple different applications, and then you have lots of different applications? It's really hard to secure all these when each one of them has a different authentication mechanism, different security mechanism. And wouldn't it be really nice if you were able to do something like this, where I just understand and know how to log on, and my phone just generally knows that I'm logged in and secure. So we're going to do this with using Chrome custom tabs. Chrome custom tabs allow you to share the user state and some other pieces, which I'll get to in a second, that give you a nice way to kind of have continuity between your different applications in a secure way. So a potential flow could look something like this, depending on the complexity of your organization. If you're using an EMM, your EMM is going to push a configuration to your device, which will have some login information set up already. I'll get to that in a little bit, what that really entails. That's going to go into your app and, probably into your SaaS backend or an enterprise backend, depending on how your authentication mechanisms and SSO are set up. This will allow you to basically talk to any type of backend, and you'll be able to mesh all the different types of authentication into one, so you don't have to worry about having different apps with different issues. So the first thing is, when you're using a Chrome custom tab for authentication, the tab, it's basically still using a system web view. So your application's not, sifting information. It's not pulling people's passwords. It's not doing anything shady. The cookies are shared, which means if you log in on a website and you go into your application, you're still logged in. You don't have to re-authenticate. Yes, and finally, just to mention, the Chrome custom tabs themselves are actually a system browser. So because they're built into Android, it's the right version of Chrome. It's not something that's compromised, and it's safe to use. So if you want help with this, there's actually, the OpenID Foundation has libraries for OAuth 2 and OpenID Connect, which will help make all this a lot nicer, so that your flow ends up being a lot simpler. And if you want to check out OpenID, it's github.com/OpenID. It's pretty easy to find. As Sean mentioned, and then there's also a talk at 11:30 from Ken Ford. Android apps run on Chrome now. They actually run as is. There are a few tweaks you might need to make depending on the type of app you have, but that's something, again, that I'll let Ken talk about a little bit later today. So there are some differences when you're talking about the types of modes on the device. So if you're using a work profile, so that means I brought my device to work and I want to allow my employer to put apps on the device, it will create a separate user space. There's separation of data, there's privacy controls, and finally, talking about a device that's fully owned by your company, that's going to be like corporate libel. There's full access to logs, and you can get pretty much any information out of it, but that's because you don't own the device. So a few things to know, and this goes for any app, basically. If your app could even run in a work profile or on a fully managed device, so let's say that, I don't know, I'm just pulling one out of the air, but let's say, and I believe Slack does this already, apologies if they don't, WhatsApp. So WhatsApp is used by a lot of people globally, and it wasn't built with a work profile in mind. So if you try to share data across platforms or across profiles, it might have been disabled by your administrator. So let's say that I'm in a work profile and I have WhatsApp installed and I'm trying to share a photo, I don't know, with my wife or something, which is going to open like the regular, let's say, I just want to share it to my photos or save it to my photos. It's on the regular or the personal profile, not the work profile. Unless you check to see if the intent will resolve, it could fail and could crash. So a lot of apps will just crash and not do well. It's pretty easy to check. You just say intent.resolve activity, and that will fix that. Same goes with file URIs. If you're going to share files between profiles, you really need to check that the URI is or you can use a file URI because that can actually check to make sure that the data can go across profile. And if you need to grant this to other apps, you can say context.grant URI permission to grant explicit URI access to other apps that are owned by you. So all the stuff I mentioned before generally can be used by anyone or any type of consumer app. Managed configurations is really where it jumps into enterprise only. So managed configurations allow you to basically push settings to a specific device to configure it for like any user, any settings that you might want or something like that. So in this case, think of like configuring email. You have an email address, server name, port, all sorts of other information. We don't recommend you push passwords through it, but if you're using certificate-based authentication, you won't need to. This works by doing a few things. Your IT administrator will have a console or some method of configuring the corporate fleet of devices. This will be setting up email addresses, servers, port names, anything like that. And that's going to push that information to Google Play, which will get pushed automatically, similar to how we push apps to devices into the app itself. To expose the different fields that your app will consume or take, there's a XML file that has to be defined. Which is called restrictions.xml. In this case, we're going to pass in a login hint, so that's basically just a string. Login hint could be email address, username, anything like that. This is like a very basic example, but this data can actually be nested, so you can actually pass in like bundles and like basically a hash map of anything. So if you're a VPN app and you want to pass in multiple profiles, you can certainly do that. You could even have a large string of basically JSON or a base64 encoded JSON to do anything you want to do. And to use this, it's actually really simple. You use Restrictions Manager, and you can get application restrictions. So if you do this on start, which is any time the app is going to enter the foreground, that's a smart time to do it. That way that every time your app is shown, you will be getting the most current settings. If you need to get settings very frequently, you can use a broadcast receiver, and if you register for application restrictions changed, you'll be able to get notified basically in real time of any changes that are happening. So obviously with like a login hit for an email, this is probably not going to be happening, but if you're, I don't know, if you're doing something like stock market, maybe your portfolio is changing frequently and you want to change the tickers that you're looking at, you could do that very quickly here. The app config community, this is something that is from basically all the different people in the ecosystem, EMMs, like us, pretty much anyone, has a lot of great information on how to do like a standard configuration. So I highly recommend you check that out. So another type of devices are basically single use. This means that things like kiosks, barcode scanners, rugged point of sale, interfaces to large equipment. This could be if you're running in a factory and you have custom Android tablets to help with running machines. Before Android Pie, there's some very specific code you need to run in order to enable this. Kiosks run in locked task mode, they're called, and this can be enabled and disabled. One interesting thing is here, if you do want to use kiosk mode before Android Pie, which doesn't require any code, by the way, you need to whitelist it with your EMM at the bottom in your Android manifest. But importantly, if you're going to use lock task mode, make sure if you're testing you have a way to like disable it in the app. Otherwise, you actually have to restart the device to get back into it because it will be locked. Lock task mode stops you from using any sort of home button, settings menu, basically anything that allows you to exit that app or modify the device in any way. So finally, let's talk about how to deploy your applications. As Sean mentioned, Manage Google Play. This is a private Play Store for you, so that's curating your own applications, and you can also whitelist specific apps to specific users. Why do we use this? So there's a lot of different features. I think everyone probably knows the benefits of regular Google Play. But for Manage Play, it adds a few extra things, like push installs, and manage configurations, and a few other things. The one nice thing about this as well is it supports private applications. And private apps is really nice because it allows you to skip a lot of the ceremony and a lot of the setup that you need when you deploy an application. As of yesterday, this was added to Fastlane. I don't know if anyone, does anyone know what Fastlane is? So we just added the ability to both enable private applications and create custom applications in Managed Play as of yesterday, which is really good timing for this. I actually, to help out with this, one of the guys on the Fastlane team who created it, I wrote, this is the code in Ruby right here, if anyone wants to do something super basic, if you are deploying it yourself. One other thing too about using custom apps, which is nice, is that one, it's a very, very fast way to deploy applications. It skips all the general checks that you do when you upload an app. One of them is the API level 26 check. So right now on Google Play, if you want to upload a new app, it has to conform to at least Android Oreo. For Managed Play or custom enterprise apps, if you use a custom app, it doesn't have to adhere to that anymore, which is pretty nice. So if you have older apps or old stuff that you just want to apply that are kind of like legacy things and you don't want to spend time upgrading it because maybe they have a small amount of users or it's something that's going to go away anyway, and you don't want to spend engineering time on it, you don't have to use this. Google Play Protect, as I mentioned, it's another benefit of Managed Play. It finds all things like this, which is a ton of different exploits that have happened in the past couple of years. This is finding new ones constantly. We're always updating it. Rollout management. Similar to rolling out a regular app on Play, you can also roll out apps with beta testing, alpha testing, closed testing. We added timed rollouts as well, or staged rollouts, as well, which allows you to roll out to a specific percentage of your user base, and you can stop this if you're finding out that there's a bug or something like that. And then finally, time publishing as well. So let's say your developer uploads something at 5 p.m. on a Friday, you probably don't want that to get pushed out right away, just in case there's an issue. You could set a time on that. One other Managed Play specific feature that's useful is delegated access. This means if you're working with an agency, a team, even in your own enterprise, if there's lots of different teams and you don't want everyone to have access to everything, you can use delegated access for different enterprises and different roles, and has very, very fine-grained permissions. Sorry. So that's how to build enterprise apps. Thank you very much. Then,
we want to leave a ton of time for Q&A.
Yes.
Mainly because the last time we ran out of time for Q&A, we were sort of scrambling in Berlin. Let me turn it back to you guys and see if there's any questions.
This is maybe just for me, but I have clients and I always get a pushback that they prefer to use iPads, which I hate, because of the stable hardware that exists, right? Like, if you get an iPad, you can kind of assume it'll have like a 5-year lifespan almost with like replacements and support, whatever. And I always push back that, okay, but it also comes with a ton of things I can't do, and so, like, as far as hardware goes, like for, say, tablets or whatever, that's like one of the things that, like, is Google doing anything to kind of like will there ever be a Pixel tablet or something, like something that like is established hardware that I can say, like, look, and I mean, in general, that's the other problem that they have with even using smartphones is it's almost a constant churn. Like, really, you're really looking at 2 years on most things, versus if you look at most other enterprise type stuff, they want 5 to 10 years. I mean, if you look at like the Office PC side, right? So if we're really going enterprise, right, we need longer longevity on the support for the devices, support for the OSs, because like, for instance, this particular phone, they dropped the upgrade, and so now I'm running, I guess, 2 versions back on this phone for Android. Well, if you're talking security issues and stuff like that, a lot of enterprises hate that scenario. So
I'll paraphrase the question because I don't know if we're recording Q&A. But basically, the question is, how is Google thinking about device longevity, how are we thinking about security updates, and how do we help on the total cost of ownership question around the Android platform, particularly given, in comparison, I think, to established expectations, both from iOS as well as in the PC market. So the short answer is there's a lot we're doing there. One, about kind of updates in general.
I don't know.
No. I don't think you are. I think one of the challenges around updates has been keeping the actual underlying hardware drivers and the baseband and all that kind of stuff updated alongside the operating system. Treble is already, so Project Treble is a project we launched around basically compartmentalizing a lot of the base hardware away from the OS. That's already starting to pay dividends. It's one of the reasons why we were able to bring third parties into the Android Pie beta program. We've also started working more closely with the silicon providers. So it used to be like we would drop Android and then Qualcomm would scramble and then they would ship. And so there's already a 6-month lag between like us doing something and the silicon providers catching up. So we brought a lot of the silicon guys in early, which also helped with things like bringing Nokia and Oppo and others into the Android Pie program. So I think we're starting to see some help there. There's other programmatic things we're doing. So Enterprise Recommended, Android Enterprise Recommended will offer at least one dessert upgrade and I think 3 years with the security updates. And it's important to mention that because we actually think about security updates much more differently than others in the market. So other platforms, namely iOS, you're basically updating the entire operating system to update Safari. You're updating the entire operating system to do other changes for security updates. And so 2 things we do there. One is we've abstracted a lot, like 3 or 4 years ago, we abstracted a lot of the application componentry into Google Mobile Services and away from the underlying OS. So let's assume you had a vulnerability where the exploit happens in Chrome. Well, we can update Chrome without having to push down an entire OS update or even a patch. So there are cases where, like, even on old hardware, even where the monthly security update hasn't been reached, because we're actually updating all the other componentry that surrounds it, the surface area of attack ends up being 0 or near 0. And so even when you look at things like what was the media vulnerability? Stage fright. Like everybody freaked out and said stage fright's going to ruin Android and like it's going to, we'll never be able to deploy Android again and thousands and millions of devices will be vulnerable. I work a lot in the security community. I've not found one demonstrable exploit of stage fright, and that's because we're often shutting down the vectors of where you would actually launch that exploit. The secondary thing I think you can do is because we're offering monthly security updates outside of the dessert upgrades, you can be running like Oreo or even Nougat and still be getting certainly Oreo and be getting a monthly security update behind it. So that helps. And finally, a lot of the security concerns that people have are things like this will lead to a root exploit or will lead to something else. And that's why tools like Safety Net are so important, because you can say, hey, I know that I have a high degree of confidence that goes all the way down to the silicon that the device hasn't been compromised. So that's sort of, for goal 1, we want to improve the, longevity security updates. Android Enterprise Recommended does that. Android One also does that on the consumer side. Secondarily, there's lots of stuff we're doing to improve bringing more devices into the fold more quickly, and you're seeing that with the Pi beta program. Certainly from an application design perspective, I'd be looking to make sure the device isn't compromised. And then finally, and I'll give a plug to Zebra here, there are OEMs that are working very closely with the silicon providers to extend the actual longevity of device updates even longer than what Google does, and they're owning up to some of the backporting patches even all the way back to Nougat, so you can get that 5-year device horizon. So if you want to buy a ruggedized tablet and deploy it and make sure it's secure, like those devices, it's hard for us to put those requirements on like a guy who's building a $75 device and releasing it on $75 unlocked in India, but folks that are building $1,000 devices that expect that longer total cost of ownership, are stepping up to that plate. So that's a long answer to a short question, but hopefully that helps.
Oh, yeah, I appreciate it.
Other questions? Yep.
I got a couple of questions about the Chrome custom tabs. First, what was the minimum API? Is that NuGet?
It should be a NuGet at least, yeah.
I think it's a NuGet at least, but honestly, given that we're requiring folks target Oreo, moving forward, you should just target Oreo anyway.
Okay.
Because to get through Google Play, you'll need to target the latest API.
As long as you're targeting Oreo.
I believe it's Marshmallow, but I have to look exactly.
Yeah, that's fine.
Yeah. Ken, you know.
How many Googlers does it take?
Yeah.
How extensible is the data store there? I.e., if I wanted to store like a store number for multi-app sign-on.
Oh, you're saying like where would you put that exactly?
Right.
If you put it in like an external storage on the device, so any kind of storage, that's probably where I would do it if you're going to share it between different apps.
Okay, so
Unless you're going to have a content provider, but that's a whole other thing. But I would probably recommend just encrypting it and putting it in a shared location.
So that's not a
Do you mean store number like, hey, this is authenticating to store 768?
Yeah, you mean like, yeah, something that like a
data store.
Yeah, like how sensitive is the data? You mean like a store number 6, if you watch The Office? Or, okay.
I'm wondering how much you could basically rely on the Chrome custom tabs for interact.
Oh, if it was in a cookie and something that's important between you, or if it was part of your like bundle of whatever however you're like the cookies basically however you're logging in. If it's part of that session already, then it'll be available.
Okay.
It'll just work. Similar to like it'll know your username, who you are, everything like that.
All right.
But you have to implement that obviously.
Are you able to access that cookie from your apps without like bringing up the custom tab? I.e., if I had a rolling timeout that I wanted to update.
It will do. It'll work the same way as like if you just open up Chrome. So if that cookie's been expired in Chrome, it's going to be expired in your app. If that makes sense.
Well, it's a like a rolling timeout. I.e., so as soon as there's user interaction, the timeout extends, and I need to update that into the cookie. Can I update that cookie without launching that tab?
I believe you need to launch the tab because I think you're going to need access to the Chrome itself to do that, and it's kind of hidden a little bit. So without actually having access to that, I don't believe it'll work. Not 100% sure, but I'm pretty sure. I've never tried that, but I'm pretty sure it require you to open the Chrome tab.
Other questions?
So in a different talk, and I've not played with this myself, but one of the guys was saying that if you create an app, that app actually has access to all the APKs on the device, regardless of what other app it comes from. And he was talking about actually making an app that can essentially go scan all the other APKs on the device, figuring out their services, and determining like vectors and stuff like that. And I was like, wow, I can't believe it literally lets you do that. So how does that reflect with regards to this idea of profiles? Will that prevent that? Like, are the APKs now only exposable within its domain, or are they still completely accessible from both sides?
So if you disable profile sharing, it should basically be totally opaque. So what John was describing, where you can do like managing intents between applications. If you're a super security conscious organization, you're like, I don't ever want consumer data to touch enterprise data, hard stop. It should look totally opaque. And so you cannot even, like, if you're deploying from pure BYOD perspective, what's called profile owner for the management side, not even the enterprise management system can enumerate what applications are on the personal side of the device.
And going along with that, is that going to stay that way going forward? Like, even if I release a commercial app, or like just a general Play Store app, I don't necessarily want someone.
I believe that violates play policy as well. I'm pretty sure that does. We're also, from a security standpoint going forward, working to lock down some of the private API calls that are allowing some of this stuff to happen. So that's going to be impossible to do soon, if you can already. But it definitely violates play policy. So if we find that you're doing that, or which Google Play Protect looks for those things, like it'll just get yanked. So it would have to have a very, very specific reason. I believe like virus scanner apps and stuff like that. There's a few like things that are okay, but you have to have a very specific reason for doing that. So you can't just be doing that for the fun of it. So there was I mean, it's a little bit different, but there's a VPN app from Facebook that got pulled because it was doing that on iOS, but that's because it was a VPN app and it was profiling traffic.
Okay.
Same kind of idea, but it would be something that would be pulled definitely.
Questions on this side of the room? You can go about that side of the room too. I just want to make sure.
Do you have any more questions?
Side of the room too. Don't neglect it. Cool. Well, we're kicking around for at least a little bit. Happy to answer any questions offline. Thanks, guys.